Thank you very much, Andrew. Now, I've been working in Antarctica for about 25 years now, and I've probably spent more than 5 years of my life down there with one person per 10,000 square miles density. There's an old saying that you go down for the first time for the adventure, and then you go down after that because you don't fit into society anymore. Now, there may be a little bit of that true, but it really isn't. If you open your eyes when you're down there, and it's not just this big white lump of ice like people, I thought so for the first few years. Robert Falcon Scott thought so. You read his journals, and even Shackleton commented, what a dead place, what an awful place. If you look around, spend enough time down there, I've actually seen climate change, and a little bit, 20 years or so down there, and seen the continent go through different changes. So what I want to do is take you to the bottom of our planet, the Antipodes, and as Andrew said, show you some recent discoveries that are just coming out. We're just publishing this stuff this year, and some of it you're going to read about in a few years from now. It'll be in widespread journals across the country, because no one's ever really been down there. So everything I've heard today has been talking about the blue and the green planet, that part of our planet. So let's see if we can't shift things and look at the bottom. I've talked to a lot of people over the last few days, and they keep asking me how the polar bears are doing down here. Well, there are no polar bears down here. They're penguins. There are no penguins in the north. Okay, and not too many people get to go down here. It's not very easy. We fly down in ski-equipped U.S. Air Force airplanes. But I want to take you down here. There's a big chunk of real estate down here, and I hope when I finish you'll have a much better picture for the bottom of our planet. Okay, how big is Antarctica? It's about 1.5 times the size of the United States. You see it superimposed here, and if you melted all the ice, it would cover the United States with 4 feet of water. I'm sorry, if we just look at the subglacial lakes, it would cover it by about 4 feet of water, and I'll talk about the subglacial lakes. If you melt all the ice, it's going to cover the United States, the coastlines, and I'm going to talk about that shortly. But here's one of the big stories here. And this is something we're really trying to explore, and it's not easy because we have this big chunk of ice on the continent, right? This ice sheet is about 2 miles thick on average. It gets up to almost 3 miles in places. But we have a few samples, and we have some ideas on what's underneath. So if we pull up and levitate, if you want, the top of that, or pull the ice sheet up, what's under it? Well, about 10 years ago, we were suggesting there were big rivers and big lakes, and now we're starting to see the results of those ideas coming to fruition here. So in this map here, you can see there's huge river basins. Some of these basins are as big as the Amazon River, and I'll show you some evidence how we measure those rivers. And then there's 150 lakes we've discovered so far, and the largest is Lake Vostok, and I'm going to spend a little time there. I was lucky enough to work with the Russians on it. We actually have some data, and we've predicted what kind of life is in Lake Vostok. This is a really big lake, and I'll show you some information. Okay, let's talk a little bit about the ice sheet. 70% of our planet's fresh water is on that ice sheet. Okay, Saudi Arabia has had plans. I reviewed a proposal where they wanted to take icebergs and pull them over in Saudi Arabia, and they did all the calculations to get so they have fresh water for the population. Okay. What if it melts? And I'm not going to, I do a lot of climate change work, but that's not going to be the main theme of my talk. But if it does melt, there's going to be a catastrophe. There's over 7 million cubic miles of ice down there, okay, 70% of our world's fresh water. And there's just a little highlight here about the bacteria in the ice itself. And these are some data that I've taken from 2 ice cores. We're doing the first biology on ice cores. If you take the bacterial carbon in that ice sheet, it's 100 times more than all the organic carbon in the entire human population. Okay, so that ice sheet, now 5 years ago, nobody ever thought that this ice sheet was alive. Now we have data showing that the bacteria are actually swimming all through the ice sheet through a network of crystal boundaries. Okay, so now we have a living ice that's really big. So I look at Antarctica now, that ice sheet is a giant lake. It moves very slowly. It's solid, but it's full of life, and there's biogeochemistry, etc. So, whoops, let's see if we go back up. If we melted that ice sheet, okay, this is what we could take a tour of Ellsworth Island from a boat like this, because that's about the water level. It'd go up about 60 meters, okay? So, and the ice sheet is melting, okay? And here's one of my favorite cartoons here. You can read that script under it, but glaciers are melting. We can, and this is going to be my only spiel for climate change, we can't look at the film running backwards anymore. It is running forward, and we cannot go back, as Carl said early this morning, and he alluded to, we cannot go back with the climate change in the South Pole area. Okay, we have to be realistic about this, and it is getting smaller, and I can now sleep with one extra layer of clothes in my tent and things like that. Okay. I showed you the picture of these giant ecosystems under the ice. These are big ecosystems, like Amazon-sized river basins. How do we know they're there? Well, we have a proposal sitting with the National Science Foundation now to go and sample an area here. And I just want to show you this part of Antarctica right in here. And this is the Ross Ice Shelf, about the size of France. This ice shelf floats over the ocean. It's about 500 meters thick. And if you look at a little place here, here's the Ross Ice Shelf here, and this is the ground, if you want, the land. There's a lot of ice streams coming here, and I've circled this lake. This is a subglacial lake. There's one here and here. And they're flat spots in the ice because the ice sheet actually floats over the lake when it gets there. There was a recent paper published last year using some novel satellite technology to actually look at that particular lake that was circled. So here's the Ross Ice Shelf right here. All the rest of Antarctica, this is sea ice. And we're going to hone into that subglacial lake right over in here. And this is how, you'll see in a minute, I'm going to give you a schematic of how these lakes and rivers were discovered. Okay, I've got two little movies to help out here. So right in here is a lake. That's subglacial Lake Ellsworth. And if you notice the shading dropped, because the lake dropped, and here's a schematic. And what happened, this thing dropped here. Now, NASA started using satellite altimetry to look at the Earth, and now we are employing those tools to look at the surface of Antarctica. It's no big flat surface anymore. It's undulating 3 and 4 meters over a 6-month period, and that's because giant rivers are flowing under the ice sheet. And unlike the Mississippi River, where there's a constant flow, the rivers under the ice sheet actually are pushing their way under the ice, and the ice on top is bulging. So that's the way it works down there. See if I can get the second one up. One more time. There we go. And this is another cartoon, and I'll show you how this works again. So this is sideways. Here's the surface of the ice. The ice here is about 3,000 meters thick. And this lake is now draining into this one, and we can see the surface of the ice moving. And based on that type of information, we can define these big lake basins under here. Now, these satellite altimetry devices, from 35,000 feet, flight levels of a commercial aircraft, can look down at a telephone book, and it can discern when you turn a page. That's how accurate they are. And that's how we're finding these rivers under Antarctica. Okay? We haven't sampled them yet. Okay, now I want to just hone in and look at Lake Vostok. This is a lake you're going to read about more in the news if you haven't already, because the Russians are getting very close to penetrating this lake. It's over here, and right off, it would be a beautiful lake if you could pull that ice sheet off, because it's flanking this big mountain range. These mountains are over 12,000 feet high, but they're under the ice. So you can see that Antarctica is quite a mountainous continent. Let's look at Lake Vostok. First thing, let's take a look from space. Okay? So Vostok's over here. NASA put this together for us. It's a really fantastic little view. What we're going to do is fly right down Lake Vostok. Okay, and then I'm going to go and show you some details. This lake is over about 150 miles long and about 40 miles wide. So here's Lake Vostok from satellite. Again, the ice is flowing across it here, and when it goes over the lake, it goes flat because there's an isostatic system underneath, and then it hits the mountains over here. Okay? This little white line in that white dot, that's the Russian station, Vostok Station right here, and this is their fuel line, support line, where they take tractor trains in to fuel the station. This is a bit of serendipity, because this ice is moving this way, and they went there to do paleoclimate studies. And little did they know there was a lake under there until about 8 or 10 years ago. This ice is flowing this way at about 2 meters a year, so in about 800 to 1,000 years, their station won't be over that lake anymore. It's going to be in the mountains. Okay, so this is a very dynamic system. Okay, so that's Lake Vostok from space. Let's see if I can get it to you, show you what it's like on the ground. Here's the Russian station. Little did they know they had lakefront property down there. All right? I don't know when the... Okay, so, and Lake Vostok was probably a lake before the ice sheet formed in this area, which was 15 to 20 million years ago. So that lake hasn't seen the atmosphere for up to 20 million years. So here's the station, and it's, of course, got the little prerequisite sign where how many miles it is to everywhere else on Earth. And here's the tractor train bringing fuel in. These guys go out there for almost a 2-month ride, and the Vostok station is at 13,000 feet elevation. Antarctic is, it's all ice under them, of course, and a lake in this case. It's also the coldest recorded temperature on Earth, and I'm going to lead in here to something else. Minus 89.2, it's about a minus 129 Fahrenheit on the 28th of July in 1983. That's without the wind chill. So it's a cold place, okay? It's cold in the air. How do you get, somebody asked me last night, we were talking, how do you get liquid water under it? Well, the air is very cold, right? The average temperature is minus 80 Fahrenheit up here. So all these guys are up, this is minus 80, okay? And what you have is the Earth has a heat source. It's got a heat generator. And it's emitting heat from the core all the time. About 50 milliwatts is coming from the Earth, and it's providing enough heat. And you have this huge insulating blanket, the ice, insulating from the very cold air temperatures. And you get the freezing points depressed, about 3 degrees, so you get a big liquid water system underneath. As a matter of fact, we just published a paper saying the largest wetland on our planet is under this ice sheet. So Great Lakes, how big is Vostok? And I'm not going to go into a lot of detail in this, but I just want to show you here, by volume, it's number 6 in the world. Okay? It's got, in cubic miles, it's got 1,300 cubic miles of water in it. Okay? By depth, it's over 3,000 feet deep. It's in the top 3 or 4 lakes on our planet. Yet, but we're getting very close. Well, what does that mean? All right, since there's a lot of economists around here. Okay, 5,400 cubic kilometers of water is 5,000 trillion liters, or 5 quadrillion liters if you want. And let's say we sell that water at $1 per liter, and that's a real deal, especially for this fancy Evian water, okay? $5,000 trillion we could make. Then we'd have overhead, et cetera. But the last time I looked, the economy of the United States, we were $1 trillion in debt. That was a couple of weeks ago, so we're probably more now. So here's a fantastic source, and we were thinking about this 5 years ago, but we got beat to it. I don't know if you've seen Daniel Kalla's new book. It was printed, I think, about 4 months ago, called The Cold Plague. Okay, and I've got through part of it. I haven't read the entire thing, but I've highlighted some excerpts. Okay, pristine water, untouched for millions of years. Obviously, he's read our papers here. Possessing natural healing powers is discovered miles under Antarctica. Okay, we actually know it's there. And in red, the scientists who claimed the water, of course, it's the Russians and the French. The United Americans were out. So you can tell what nationality he is. They want to make billions of dollars selling this water. He stole our idea, in this book. However, after they sold it, this mad cow disease broke out, and the planet started killing everybody. Okay, so here's Dr. Noah Haldane down here. He's got to save the world, and so I don't want to steal his thunder. You should read the book. But a recent New York Times preview of the book goes on and says, "But it could really happen." What a thriller! Okay, I have consumed water from Lake Vostok, and I'm not dead yet. So maybe the plan still works. Anyway, a lot of people are going to see this more and more. He's making a lot of money on that book. Let's look at Lake Vostok in a cartoon, because you can't see it under all the ice. So in a cartoon here, we have a system where there's about 2.5 miles of ice. It's flowing, and you can see it flattens out over the lake. And there's a lot of things I want to show you here. Here's Vostok Station. They cored down and hit some very funny ice. We now know that in the northern part of the lake, there's melting and refreezing in the southern part right under Vostok Station. So this ice here represents Lake Vostok water that froze to the bottom of the ice sheet. Okay? So I've worked with the Russians, and we've actually sampled the water down here. We've extracted DNA. We've looked at what kind of organisms, and there are a lot of novel ones that we've found that are in this ice, which represent what's in Vostok. And then we got an idea how they make a living after being isolated for 20 million years and in the dark. There could be geothermal. There's evidence of geothermal, and if there's a lot of geothermal, we could get a whole tube or a vent community like we see in the Galapagos trenches and the rift zones. We just don't know. It's not easy to sample. Okay? One thing I want to note here, the Russians are drilling. They stopped because of environmental pressure back in 1997. Scientists said, stop, you're hitting this very interesting ice, and there's a lake under there. And they did stop 2 years ago. They started drilling. Their drill's now stuck at 3,666 meters. They have plans to get the drill out next year. This borehole, they use drilling fluid, it's kerosene, and there's 65 tons in there. So there's a lot of environmental concern about what happens when they go through. They're 80 meters, okay, about 250 feet or so from penetrating that lake. And their drill is jammed in right now. And they will go, their head of their program has told me personally, and it's been published, that the United States beat us to the moon, they're going to beat us to Vostok. So that's happened to our funding is the United States now is withdrawn because we don't want to be part of this race. And I'll buy that. One thing, I had an international committee on trying to get into these lakes. We need a drill. We need a clean drill. And I'm telling you, we've had a number of workshops funded by the federal government. We've had Halliburton there, a number of drilling companies. But what scares them is gases. Because there's about 10% of this ice is gas. That's how we tell the climate record. That's where we know there's CO2 and methane, et cetera. Well, so it melts into the bottom, it refreezes here, and the ice, this accretion ice goes out. But it's less than 1% gas. So where does the gas go? It goes into that lake. So we did some calculations and published a paper showing that lake would be supercharged, much like a Coke bottle. So anybody's looked at a Coke bottle, and this is a 2-liter Coke bottle, and these kids have set this off, and you can see this, okay? How many? That's 2 liters, okay? Lake Vostok is 5,000 trillion liters, okay? Now, we've done our math, and there's a hole this big. And we published this in a journal of geophysical research, and it's just math. The geyser will go 3,000 feet in the air for 4 months, okay? And it'll kill everyone at the surface because you're taking the water in Lake Vostok near the surface is -3 centigrade. It's still liquid. That's warm. It's going to go into -80 Fahrenheit air. Now, one thing we do in Antarctica when we get bored in our tents is boil water on our Coleman stoves when it's -50 and throw it outside, and it blows up. It goes through a phase change, and latent heat given off is explosive. You know, I don't know how many people do that, but this is what's going to happen. Honestly, it will. So when we presented these data, Halliburton pulled right out. They do not like gas pressure. And the Russians know this. And I've tried getting them personally. I've talked to the head of their program, and they are not going to budge. So we're not sure what's going to happen. But you will read about it, I guarantee you. Okay? It would change the climate in Antarctica. Okay. I just want to tell you a little bit about what to get funded. All of our funding is pretty much from the National Science Foundation. I submitted a proposal to search for life in these lakes. And here's an NSF reviewer, okay, goes through about 6, 7 reviews, and called it a fishing expedition. And, you know, it was, come on, get going here. So there was obviously no sense of discovery by this reviewer. So I conjured up these ideas of so we're going to go out in Vostok and put out a little fishing pole and sit there, and what are we going to catch? And I thought maybe we should put that reviewer out here, you know, because this person had no sense of discovery, obviously wasn't thinking out of the box. So, you know, we don't know what's under there, but there's probably no charismatic megafauna. Okay? And when you work on bacteria, everything else is charismatic megafauna, right? Okay, this is what we found. Okay, bacteria and a lot of it. Okay? And how will we sample it? This has been a real problem. This is an artist's rendition. How are we going to get through over 2 miles of ice and sample? We're going to send maybe a little melting device down through, open a little door and put a robot there. And we have to look at this on a large scale. Okay? It's like you can't just go into the middle of the Pacific Ocean, take a cup of water and say, this is what's going on in the Pacific Ocean. We need to look around. So what we've done is we've got funding now, it's through NASA. Okay? We built a submarine. We joined up with Stone Aerospace in Austin, Texas, and built this robot. This is a really smart robot. There's no GPS under the ice, so it's got to figure out its way. So this is a test that was done. This is the robot. It was done in Lake Mendota, February. A good start, and it worked. A lot of press was covering. And it's on its way, and I leave for Antarctica in about 3 weeks, and we're going to put it in this lake here. This lake has 20 feet of ice and about 200 feet of liquid water, and it's going to go down, and we have instruments on it to search for life. It's going to map the system, and it's going to figure it out on its own and then come back to us, we hope. That's $7 million of hardware right there. So here it is. The last test was last month at the Johnson Space Center. This is my last slide, Andrew. And this is our little Endurance. And this is, and you can see, this is a mock-up of the space station where the astronauts go and do their weightless thing. And we wanted it to do a round-trip circuit around there, around the whole thing, and miss all this. You can see it figuring its way. It's got sonar all over, and it's figuring out where it's going. And it's going to come right back up to where we wanted it. Okay? So with this test, we shut it down and didn't touch it anymore. It's now on a C-17 on its way to Antarctica. Okay? And we will know, and you will probably hear about it, National Geographic's giving partial funding. Okay? So, to end it here, the old view of Antarctica, and it's the view I had 20 years ago, a lifeless polar desert. Not anymore. It's not all this big lump of ice. We now know it's a subglacial, and the ice itself is an oasis for life on our planet. And it's one that it's just ripe for discovery. Every time we turn around, we're finding more. Thanks a lot.